Okay, so for the video solution assignment, I decided to do one of the problems that was on a learning module that was also similar to the last question on the homework that I know a lot of people had a hard time with. So the question states that a 5 centimeter tall object is placed 50 centimeters in front of a diverging lens with a focal length of negative 35 centimeters. A converging lens with a focal length of 25 centimeters is placed 10 centimeters behind that diverging lens. The question wants to know what is the image distance for the converging lens and what is the total magnification. So the first thing I did was attempt to draw a picture somewhat to scale. And so here's the diverging lens, and then 10 centimeters behind it is our converging lens. And I went ahead and called converging lens, lens 2, and diverging lens, lens 1. And we know from the information in the question that the object is located 50 centimeters in front of the diverging lens, and it has a focal length of 35 centimeters, and it's negative because it's a diverging lens. And we also put here that the object is 5 centimeters tall, but we won't need that until later. And so I went ahead and set up my first lens equation, which is 1 over the object distance plus 1 over the image distance equals 1 over the focal length. And so we rearranged it some and plugged in our values, and we're able to find that Q1 equals negative 20.59 centimeters. And since Q, the image distance, is negative, we know that it's on the left side, or the virtual side, of the diverging lens. So next we can plug it in and try and find the object distance for P2. And our new object is actually the image from the first lens. So P2 is equal to 20.59, and I did the absolute value because we don't want the negative in there, plus the 10 centimeters, which is the distance to the converging lens, and we got an object distance of 30.59 centimeters for the second lens equation. So now we're looking for Q2, which is the image distance, or our final image distance after going through the converging lens. And we know that the converging lens has a focal length of 25 centimeters. So we once again rearranged the lens equation, and we're able to find that Q2 is equal to 136.81 centimeters. Okay, so I attempted to draw this in the diagram, and I put the initial image after the diverging lens right here, and we drew some rays and I traced it back, so that means it's a virtual image. And then I attempted again after finding the final image to be way out here to draw it, and obviously it's not quite to scale, but it still actually worked, and we can see that the final image is inverted and certainly larger than was our original image. So next, we've already answered the first part of the question, which is the image distance. So now we're looking for the total magnification, and magnification is equal to the image distance divided by the object distance. And so we have to do this equation twice, once for each lens. So for the first lens, we got a magnification of 0.41. So this indicates that it is a upright image because it's positive, but it's less than 1, so it's smaller, and that we can also see in the picture here. Then for the second magnification equation, it's negative 136.81 divided by 30.59 centimeters for a final value of negative 4.47 magnification. So the negative tells us that it's going to be inverted, and it's much greater than 1, so it's going to be larger than our image. So for total magnification, we simply multiply the two and get negative 1, or get 1.84. So if we wanted to find the image size, like in the learning module, we would just multiply 1.84, the magnification, times the initial object height, which was 5 centimeters. So our final image would be 9.2 centimeters tall, inverted, and a real image. And that, I think, covers everything.